So students, today we begin a new chapter, and the name of the chapter is Trigonometry. Trigono what? I know sounds like a little. I think it's a new word for you guys. You have not studied about this till now. So let us, look at the word a little more closely, and let us split the words. Trigonometry. Now, tree. What does that mean? Hmm. You might have heard of the words like trio, triplet. Have you heard words like that? Do you know what that means? Trio means a group of three, like three voices coming together. Triplet is a group of three, especially when all three friends always walk together. We call them, oh man, they are always or they are like a triplet, and three babies being born together. We call they are okay. They are a triplet. So again and again we see three coming up. Trio is three voices, triplet is three people being together. So three means three. Okay. Gone. Gone means what does gone mean? Well, let us think about few things which we have seen with gone. You have seen or heard about pentagon? That is what a five-sided shape, five-sided polygon, right? Ah, and hexagon, a six-sided polygon, and of course the word polygon. So all these three words, has the gone in it. There are other words like heptagon, octagon, and yeah. So what does gone mean? Think about it. Now looking at all these things, we feel gone means sides, but it actually doesn't mean sides. Because it means angles. Now because you look at pentagon, you see that there are five angles, right? 1, 2, 3, 4, 5. And if you look at hexagon, you see that there are six angles. 1, 2, 3, 4, 5, 6. Do you see that? So therefore this gone means that is why it gets the name pentagon, it gets the name hexagon. Pentagon means five angles, hexagon means six angles. Hex means six, penta means five. So and poly means what does poly mean? Remember when you studied about polynomials, you studied that poly means many. So of course here also the same thing, poly is many, and gone means angle, so many angles. Okay, let that be it. Now we'll see ometry. What is ometry? The O doesn't matter here. What matters more is the metry, the word metry. Now, what all words have you seen? Have you heard about this word audiometry? Okay, there's another word, photometry. Okay, maybe you might not have heard of these words, but there's one word that you're all familiar with, geometry. And so what does all that mean? Well, let me start with audiometry. Audiometry is a measurement of audio signals, measurement of audio signals. Okay. Photometry is a measurement of light, measuring measurement of light. Phot means light. It is a Greek word which means light. That is from where you get the word photosynthesis. Also comes from phot. Then you get geometry, and this word geo means earth. Actually geo means earth, and metry means okay, metry is what you're gonna study. So in geometry you study about sizes, shapes, lines, distance, space, and these kind of things. So it's a measurement of shapes. So what word did you see common in all these things? Measurement. And of course metry means measurement. Okay, so the whole word trigonometry means three angles measurement. So tell me, which polygon do you know with only three angles? And that polygon is triangle. 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 Tri means three, angle means angle. So three angles, that means a triangle. Okay, so I was till now I only explained what the name means. I think from that itself you understood what the chapter is all about. Of course, yes, the chapter is all about triangles. Now I'm taking you to a different world here. In this here, forget about all what we saw till now, and just imagine that you are standing on a somewhere, and there's a tall tree in front of you. How do you calculate the distance of the height of the tree? How can you calculate the height of the tree? Of course, there are one way is you just climb the tree and find the height, but that would be really difficult. It would be really difficult because and dangerous too. Climbing up to the top of the tree. But there's an easier method, and that easier method is through trigonometry. So let us see how we do that. So this is the height of the tree. So let me draw a straight line from the top of the tree to the ground. Then from this point I am going to draw a line to the place where I am standing. Imagine this is me. Okay. Then I'm going to join these two lines. So yeah. So I now get a triangle with three angles. One angle here, one angle here, and one angle here, and this is a 90 degree. So fine. So I get a right triangle, a triangle with a 90 degree. Now let us focus on this triangle. This triangle will be our focus point. Okay, we will be focusing on this angle for now. So this height of this, so this is our triangle, and what I'm going to do this height of the tree, this height of the tree, I'm going to bring the line a little more closer. See, and now I get another triangle. Do you see? Now I'm going to bring the line a little more closer, and I get another triangle. Do you see the triangle getting smaller and smaller? Now I'm going to bring this line a little more closer. See what happens. I get another triangle. Now what do you see in all these things? What do you see in all these things? When the triangle gets smaller and smaller, you see there are two triangles here. This all the sides of the triangles became small in an equal way. Here again the triangle gets smaller. The triangle gets smaller and smaller, or in an equal way. All the three sides of the triangle are getting smaller again in an equal way. What is happening is this side and this side, the lengths and the base also, everything is getting smaller. So you see that it is getting smaller and smaller equally, and all the three sides are getting smaller. So what do you see? The ratio of all the sides are same, because all the sides of the triangle are getting smaller equally. What do I mean? We will see that. And by the end of this video, I think you'll be able to understand that statement. But just read that statement and try to think about it. Ratio of all the sides are same because all the sides of the triangle get smaller equally. Now this was a triangle. Then that triangle we made it to a smaller triangle. Then this triangle we made it to a smaller triangle. Then this triangle we made a smaller triangle. In all these triangles there is one thing common. Did you see that? One is the ratio. Another thing is, look at this angle. This is the angle for the black triangle, right? Now this is the same angle for the blue triangle, and that is the same angle for the violet triangle, and that also is the same triangle for the pink triangle. Do you see this, students? Whatever be the size of that each of the triangles, this angle was the same. it remained the same. Of course, that is why the ratio also remained the same. That is why the ratio also remains the same. Both are interconnected. But for now, see that the angle remains the same, and that is a very important point, because that is the only reason why we are able to do all these things. Okay, now imagine that this side is 5 meter, and this length is 4 meter of this triangle, okay, and the black triangle. So the ratio of this side by the hypotenuse, or this length by this side, is 4 by 5. And as I said, because the triangle is getting smaller equally, in an equal way, all the sides of the triangle are getting smaller in an equal way, therefore the ratio of the ratio should be the same. So this side 10 meter by this side, it should also remain the same, and it is. You get it? 8 by 10 is equal to 4 by 5. So what did I do here? I did, what I'm trying to show here is the ratio of the sides of the triangle remains the same throughout, because the angle is the same. Okay, that is what I'm trying to show here. So if it is 4 meter and if it is 5 meter, the next triangle side also will be in the same way. For example, if it is 8 meter, this side will be 10 meter. If it is 10 meter, this side will be 8 meter. Okay, now let me take another side. For example, take this side, the white line. Imagine it to be 3 meters. Imagine. Then this is the ratio, 4 by 3. This side by this side is 4 by 3. Okay, then I'm considering this side again, 8 meter of this triangle, and I'm considering this base, this full line. What is that? I don't know what is that. We'll try to find out. So I'll write 8 by something. I don't know what is that. I need to find it out. So 8 by something is equal to 4 by 3. That means, okay, remember when I was teaching you linear equations, I told you that when I don't know something, I call it a variable. So I'll put a variable there, 8 by x. So now I know, even though I do not know what is the value of this line, I know an equation, I know the ratio, that it is 8 by x is equal to 4 by 3. So with that ratio I can find it out. So let me do the calculation. 8 by x is equal to 4 by 3. That means 4x is equal to 24, which means x is equal to 24 by 4, which means x is equal to 6. Wow. Okay, now so that is 6 meter. Remember to put the unit as meter. Now what about this? I mean, let us come back to the original point, and the whole point of this thing was to measure the height of the tree. So imagine this side and this side. So we will call this side as our height, h. We don't know what is the height, right? That is what we need to find. And this side, this base, the full base, we will call it L. The length, or L, just we'll call it L. So L we can kind of find out. We can take a measuring tape and we can find out, and I found out, because it is on the ground, so I found it to be 12 meters. But I don't know what is the h. I don't know what the height of the tree is. So but I know that the ratio is 4 by 3, because in this small triangle it was 4 by 3. So I know that this height by this 12 meters, that is 4 by 3. Even though I do not know the height, I know the ratio. So I'll write h by 12 is equal to 4 by 3. So I can, similarly like what I did before, I can do calculations, and I see that 3h is equal to 48, h is equal to 48 by 3, and h is equal to 16. Wow. So I can write h as 16 meters. Guys, did you see what just happened? Instead of climbing the tree and breaking my leg, what I did was I found the height of the tree without climbing the tree. So you see how useful this concept of a same angle and a constant of constant ratio and the concept of constant ratio, how that helped us to find this. Do you see how it all came together? How the values of this small triangle helped us find the height of the tree, the big triangle. And this is not only to find the height of it, you could find this side also. This side also you could find with the same concept of ratios. And not only the height of the tree, students, you can, even if there is something that is way tall, like the tallest tower in the world, anything, any big height which is impossible for man to climb and find out, you can easily find out by the concept of trigonometry. Okay, you will see a proof of this, uh, not a algebraic proof or anything, but a very visual proof of this in the last, okay, in the last part of the lecture series, last or the second last part, near the last part of the second lecture series, you will find a living sorry, not a living, a visual proof of what I just showed now. So keep watching till the end of the series. Okay, now, so remember, this is a right triangle. Okay, what we got was a right triangle. Now, that is all for this video. It is enough thing I think there is enough to think about. If there's something that you didn't get, please rewatch the video and try to get it solid in your mind. And if there's any doubt, just contact me. Thank you.